Do it.
Have you seen Look Perfect?
That was green.
No, Look Perfect. The guys that make YouTube videos. No.
Oh, I didn't make one.
I will show you.
Okay.
A bunch of the 80,
You know, I think we should take a break and go to
85,
the
86.
electrical senior design lab and just say, yeah, we got ours working, and then that's where, you know, just high
Anyone?
five each other.
When Ty comes in at like 3 in the morning, we're like here.
She's a mom.
We're like sleep.
Yeah. Oh, yeah.
Now, let's talk about the projector system, the section that will be in charge with the user interaction and to provide feedback while the authentication takes place. First, let's take a look at what's inside the housing. The first component of our system is a heatsink, where the GPON board LED is mounted. All the light produced by the LED is redirected by the reflector and the Fresnel lens. This will produce a collimated beam of light that will pass through a polarizer and the 3.9 inches LCD to generate a color image. To reduce the light loss in the system, a second Fresnel lens is used to gather the light. A set of two mirrors is used to fit the length of the image projection inside the device. A Cooke triplet optical system is mounted with a 147mm by convex lens, a negative 50mm by concave lens, and a 16mm by convex lens. And yet, at the end of the system, we use another mirror, but this time the path direction will point downwards. Once everything is set up, the projector will help the user to place the hand in the right position. Placing the hand too low or too high will not display a focused image. This will guarantee that once the image is properly focused, the hand position is in the right place to be in focus with the camera as well. Now, let's see a quick demo of the projector interaction with the user. Once the hand with the right command gesture is recognized, the new user registration will start. After the images are captured, a success image will be displayed on the user hand. Then, for signing up, two fingers have to be extended and the process will take place once the hand is recognized. If the user was previously registered, a positive image will be displayed. However, when an unregistered user tries to sign up, then a failed image will be displayed.
Hi everyone, this is Jessica. I'm going to be showing you the image acquisition portion of the project. In our project, there are two cameras. There is our near-infrared monochrome imaging camera that is used specifically for the vein pictures that will be processed through machine learning. And then up here, there is a computer camera that we have been using in order to make commands by hand gestures. So this top camera does not image any veins, it is used only to take hand commands. And this bottom camera is used to image veins. So here is a quick look at our housing. Here's the projector, and so while the image is being processed by the machine learning side of the project, it is giving you real-time feedback of scanning and failed or successful attempts by the IR authentication system through the projector. So here we can see a quick video of our setup for the bottom portion of the housing. So we have the camera, which is plugged into the Nano, and we have our center mirror, which we put our hand above, and we have our lighting source. Now this bottom portion of our housing does have a lid, but to show you guys the inside, we took the lid off. And then a clearer picture of this bottom side of the housing, which is the imaging portion. So here we can see the center mirror. So our user would place their finger above the center mirror for the camera to get a picture of their veins. This light source has been adapted to be at a degree so that it is always on your finger at this angle, which is a few inches, about 4 inches above, so that it is always in focus with the camera, and it is always in focus with the projector. So the user would place their hand along this line, and it would always be in focus with the 2 optical systems. So this is the lighting system, and here it is the driver for the LED, the 780 nanometer 22 milliwatt LED, and the optical diffuser to get rid of any center intensities in the picture. And the rest of the mirrors are to adjust for optical path lengths in order to get the correct field of view for the imaging system.
Going over the commands for sign up, the first thing that we can see in the image is a QR code. The QR code is used as a security method so that not everybody can sign up. Only the user who has a QR code can proceed with the sign up process. The QR code is scanned by the webcam, and then the user proceeds by placing their hand inside of the device. Looking at the monitor, so it's easier to see in this image, the user has to align the blue block with the purple block, and while they're doing that, a few timers are running in the background to provide the user with enough time for them to place their hand in the correct position. Once the timers have finished, the capturing of images will begin. The capture images is done using the sensor, and they will be stored locally, so for the future when the user wants to log in. For the command of login, the user will begin by placing their hand inside of the device with both the index and the middle finger extended completely. Once that has been done, the user needs to align the blue block, which is their middle finger knuckle, with the purple block to have the system aligned. They have a limited time to do that, and once that timer is finished, the capturing of images will begin. Once all the images has been captured completely, they will be passed to the machine learning aspect of the project, and based on the result the machine learning returns, we either get a success, or if the user is not the correct user, we will end up getting a failure message.
So here we have some test results that were captured earlier. The names on the top of each column signify who should be eligible for correct authorization. As we see here on the first column, where when Jordan goes, he fails only once in the 7 attempts. When Emmanuel goes, he fails 6 except for the 3rd attempt. And then Francisco fails all attempts. When Emmanuel is in the database, Jordan only passes once. Emmanuel passes 5 times and fails twice. And then Francisco still fails 7.
The PCB of this device works as intended, where we have a input at our micro USB port supplying voltage into our device at 5 volts DC, which is then converted to 4.2 volts DC, which charges our lithium ion batteries. When not under the supply of the wallet, we can see that our batteries are supplying power to our 5 volt DC and 12 volt DC output voltages. We tested this using the IR LED driver and the IR camera for this device, which successfully turned on and operate.